Okay, so you're doing the atmosphere investigation, where it says that the students will explore the effects of changes in atmospheric pressure on water and air. So the first thing you need to think about is to describe a time when you have experienced a change in air pressure, right? So think about, did you ride in an airplane? Did you swim in the pool and go under the water and your ears popped? Think about a time when your ears popped. Even riding in the car, going up through the mountains, your ears pop. So describe a time when you've experienced a change in air pressure. And the materials for our lab are the vacuum chamber and the pump, the pre-filled water balloon, a pre-filled air balloon, and we have a 40 milliliter beaker of water, which also has a test tube in it, 40 10 milliliter test tube, and then of course a peep. This is, I think it's Kevin. So basically in your background area, we talk about the term atmospheric pressure, and it describes the force applied to an area by the molecules of air that make up the atmosphere. A force can be a pull, such as the force of gravity, or a push, as in the case with the atmospheric pressure. At sea level, the atmospheric pressure pushes at the rate of 1 kilogram per square centimeter. And then this means that the atmospheric pressure is pushing on the tabletop with the force of 8,000 kilograms. So that's more than 3 large SUVs sitting on this tabletop. The reason that the table doesn't collapse from the atmospheric pressure because it's pushing in all directions, right? So the bottom of the table is pushing up, and then the cabinet, the tabletop is pushing down. So a vacuum is an area with little or no pressure from gases like air. A vacuum chamber lets you pump away the partial vacuum, lets you pump away the atmospheric pressure from inside the chamber. That's what we're gonna do. We're gonna take out the air. So one result will be a difficulty in opening the top when a partial vacuum is present in the chamber. Since the top of the chamber has a surface area of about 150 square centimeters, 150 kilograms of atmospheric pressure are pushing down on the top, and very little pressure is pushing back from the inside of the chamber. So lifting the top while a full vacuum is in the chamber will be like lifting the top while 2 students were sitting on top of it. The strength of atmospheric pressure is something most people overlook, but it plays a major role in the weather. So what I want you to do now is look at number 1. If you pump the vacuum chamber to below normal atmospheric pressure at sea level, will one of the students in your group be able to take the top off? So that's what I'm gonna do. Well, make your prediction first. $15 pumps, okay? And now take turns trying to take the lid off. Try it. It doesn't come off because it's the equivalent of 2 students sitting on top of it. All right, so what you need to see is that question for number 2, okay? How does this prove that the atmospheric pressure exerts a powerful force, right? So the difficulty that we have taking the top off definitely supports the atmospheric pressure that it exerts a powerful force, okay? So now we're gonna turn the page to number 3, or you're gonna stay on the page you're on for number 3. And we're unable to open it, so we're gonna let the air back in. And before we pump this time, the question is, if you pump the vacuum changer to below normal atmospheric pressure at sea level, what would happen to the water-filled balloon inside the chamber? So make your prediction. What's going to happen to that water-filled balloon inside the chamber? Okay, and then we're going to place the water filter balloon inside the chamber, which I did. I used 15 strokes to pump the air out. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, there we go. So now, what happened to the water balloon? Can you see it from there? What happened to our water balloon? Absolutely nothing. Okay? So I guess the question is, why did this happen, basically? Number 5, what happened to the water-filled balloon when the atmospheric pressure decreased in the chamber? So you're probably going to put like nothing. 6, if you pump the vacuum chamber to below atmospheric pressure at sea level, what would happen to an air-filled balloon in the chamber? That's a good question. All right, but let's get back to this balloon full of water. Okay, the volume did not change because liquids have a definite volume. I'm going to release the pressure. And liquids have a definite volume. So there's a definite volume in this water, okay? There's not necessarily a definite volume in the air. So we're gonna put our air-filled balloon in here now. And our question is, you need to make a prediction. If you pump the chamber to below normal atmospheric pressure, what's gonna happen to the air-filled balloon? And then your task is to place the air-filled balloon in the chamber. Use 15 strokes to pump out the air, and we're gonna see what happens. So what do you think happens? Can you see it okay? Yes, you can. Here we go. Ooh, getting really hard to pump it. Whoa. What happened to the balloon? Can you see it? There we go. So what happened to our balloon? You're going to write that down. Write down what happened to the balloon. And then for number 9, it says, why did this happen? Okay? So the air pressure in the chamber was reduced, right? And that caused the air to expand. It's like we're giving it a big, huge hug. It's so tight in there. So now we're going to carefully observe the balloon as I press the knob. Get everything. There's so much reflection here. There we go. So what happened to our balloon? All right, explain why this happened. So that was 11. What happened to the size of the balloon? 12. Why did this happen? Okay, air changes volume as pressure changes in the vacuum chamber. That's what happened. 13. Was it water or air whose volume changed as the outside pressure changed? That's a good question. I'm pretty certain it was the air, right? So we've got air changes volume as pressure changes in the vacuum chamber. Yes, that's what I was trying to say. So when you're letting the air pressure back in from the room, basically, normal air pressure returned to the vacuum chamber and it forced the air inside the balloon back to its previous volume at normal air pressure. Alrighty. So now we are going to do the lesson 2 part, which is the effect of the atmospheric pressure on the water level within the test tube. So you're going to draw the water level of the test tube in frame A or a figure A on the next page. So here is our water, our test tube. It has water in the beaker, but you can also see the water in the test tube. Okay, so that's what I want you to see. So the original water level is what you want to draw on your paper. This is really hard to see. Let me get it closer. There we go. Now draw the level, the water level from starting, okay? And then what we're gonna do is put it in the chamber. Okay, trying to figure out how I can do this for you to be able to see it better. All right, this is gonna be perfect. So now watch your water level. You can see the water level in the test tube. Right about there is good. And now I want you to watch the water level in the test tube, because for number 8, you're making, no, I'm sorry, for number 3, is there air and atmospheric pressure inside the test tube? Yes, there is. Okay, and then where is the air inside the test tube pushing? Would you say like it's pushing up, it's pushing down? So the air inside the test tube, it's actually pushing in all directions, including down on the water, right? So then you're gonna make a prediction. What do you think is gonna happen to the water level in the test tube when you remove the atmospheric pressure from the chamber? All right, so write your prediction, and here we go. Pretty cool. Now on figure B, you're going to draw the water level for frame B, the water level after pumping, the water level that's in that test tube, or not in that test tube. Pretty cool. So for number 8, you're going to make a prediction what will happen to the water level in the test tube when you increase the atmospheric pressure in the chamber. Remember, we just took all the pressure out. So when we put the pressure back in, what's going to happen? Okay? And then you might have had bubbles. I, of course, wasn't seeing it. You can see there might have been bubbles escaping because the air pressures in the vacuum chamber is reduced, and the air pressure in the test tube forces the water level in the test tube lower, and it forces some of the bubbles of air out. All right, so now I'm gonna let the water out, and you're gonna make a prediction or not. I want you to just carefully observe the water as I let it out. So then for 10, you draw the water level for frame C, in frame C. All right. So how did air pressure affect the water level in each drawing? So basically what happened is that the water level dropped when the air was pumped out of the vacuum chamber because there's less air pressure, right? There's less air pressing down on the water in the beaker. But the water rose when the air was let back in because then there's more air and it was pressing down on the water in the beaker, which pushed the water back up into the test tube, and so it had less air. Okay. So there we go. So on the back page, I want you to think about if you went up to Mount Everest. As you go up to Mount Everest, the air pressure drops because there's less air. At the top of Mount Everest, the air pressure is now 70% less than at sea level. If you travel below sea level to a place such as Death Valley, the air pressure increases because there's more air pressing down on you. So describe what would happen to the air balloon from this investigation if you took it from sea level to the top of Mount Everest and then you returned the balloon to sea level. And why would that happen? So basically, as you're climbing higher and higher, the balloon is going to get larger and larger because there's less air pressure pushing on the balloon. And as you climb back down to sea level, the balloon would return to its original size. All right, so we're going to pretend that this little guy, Kevin, okay, he's going to go hiking Mount Everest. Here he goes. Bye, Kevin. Okay. So he's hiking, and basically we're going to take all the air out of the vacuum chamber. Here's a side view of Kevin. There we go. And as we hike up, he's getting a little short-winded. He's getting a little tired. He's like me, he has asthma, so he's getting less oxygen already. And as he gets to the top, there's less air pressure because we're taking it out. Okay. Deep breath in, Kevin. There he goes. Okay. Oof. So there's like they're talking about the balloon would expand, right? It's going to get larger because there's less air pressure pushing on him. But then as you climb back down to sea level, he returns to his original state because there's more air pressure on the balloon or on Kevin as you're going back down. And that's your atmospheric pressure investigation.